Okay, shout out to Michael Augustine for creating this GIF a couple of years back. This is Blake Snell's EV ecosystem. When he went crazy in 2018 and ran away with the Cy Young, the 2 years previous to that, he focused his fastball on the outside part of the strike zone. By moving that and literally nothing else, he gained 1 mile an hour in real speed, but he gained 7 EV miles an hour by where he located that speed. By locating your fastball up, it immediately changes everything. By creating this ecosystem, what that means is that he has thrown these pitches that come out of the hand and they look absolutely identical. This is 3 pitches going to 3 different parts of the strike zone. Now, if he were to throw a fastball down and away, it would have a very different look out of the hand. And then the slider would pop over that. The curveball in the strike zone would pop a lot over that. And so it would be a very, very different look. But what you're seeing here is you're seeing 3 pitches look absolutely the same. Curveball goes out of the strike zone. The fastball stays up and in where it forces the fastest possible reaction time. And then the slider moves away about 14 or 15 miles an hour difference in reactionary time. That's a crazy difference between pitches. So where pitchers get in trouble is they start messing with 2 things. One is the EV miles per hour of their pitches. So this 96, 97 fastball that he possesses, that thing either turns into 100 or it turns into 93, depending on where he uses it. Where he used to use it at 93, it didn't hide pitches and hitters had more time to react to it. When he stops doing that and he focuses on 100, it forces their attention to go faster. And when they have to respect 100 miles an hour, they start making poorer decisions. It's simple as that. Every study has always shown that. When you take away time, guys' reactionary, their skills at being able to identify things goes down significantly. So this is what his pitches look like that season. He focused his fastball up. Changeup was off of that. You can see the epicenter is on the black. The epicenter here is on the black. So his curveball is staying in that basic area. And the fastball is significantly faster than it was the season before. So in essence, he's keeping the red pitches red. And if he wants to go to a different part of the strike zone, he does it with a pitch designed to do that. The changeup's designed to look like fastball, but go somewhere else and go there slower. That's the whole point of true pitch design. It's not about trying to make the changeup move more. It's about trying to make the changeup look like the fastball and then move to an area where it's slow enough to create that speed differential. Same thing with the curveball. So when you look at data and you start to see pitches get jumbled more, then you start to see these numbers creep up. He still has amazing stuff. I mean, he's not a guy that has average stuff. His stuff is very above average. But when the pitches start to blend, then it starts to create chaos, and that is never in the favor of the pitcher. Chaos is the hitter's friend. Because when you throw fastballs down and away, all of these sliders that are in the same area as that fastball, they have a different look out of the hand. Simple as that. The curveball pops big time. The fastball is away. The slider is away. When that combination happens, then the visual goes away, and all these numbers start to creep back up. Even with great stuff. Great stuff is why this isn't 98 or 96 exit velocity. But 90 is still too much from my perspective for a guy with that kind of stuff. When you look at fastballs just exclusively up at the top of the zone against lefties and righties, there's still some confusion in there, and there's still some crossover happening. But by and large, the numbers are significantly better when you eliminate that pitch at the bottom of the strike zone. That's not designed to be there. Now, on occasion, a freeze fastball away and down, great. But as soon as it starts to become a thing, as soon as it starts to become something that where you focus on it, or you see, like in this case, you see these changeups that are 87, 88, 89 miles an hour ending up on the plus side or ending up right on that diagonal, then you're going to end up having less of that pitch doing what it's designed to do, which is to go to that outside area where he lived in the year that he absolutely dominated hitters. Fastball in, curveball in and down. So a sea of blue is what we would see if we looked at a perfectly used. You'd see a splattering of curveballs here, but you'd see the bulk of them at the very bottom of the zone and below, because those are that great chase that we saw in the GIF. But when you start to see the whole zone fill up with pitches, that indicates that there's some randomness, and randomness again helps the hitter. So what you'll see tonight is, if you see this, a sea of red at the top and the green pitches where they're supposed to be, like in this case, if he threw them to lefties, which he does not, they would be in off the plate because it would come in off of that same tunnel. And then you'd see the blue pitches going to the blue area. Let me get a blue color over here. So this is the blue side of the zone, and you've got the red side of the zone. Keep the red pitches red and keep the blue pitches blue and keep them coming out of the same tunnel. And that's the recipe for eliminating exit velocity.